Hi everyone, I'm Arvind Pillai and I will be presenting our work MoodCapture, a depression detection framework using naturalistic smartphone images. Depression is a major public health issue that affects more than 250 million people worldwide. And with the increasing rate of depression, it is crucial that we create new tools for detecting or screening depression. Most current methods that diagnose depression, such as clinical interviews, require the person to come into the clinic and talk about their symptoms and experiences. This has a high burden, and the individual might not remember their past experiences accurately, which leads to recall bias. In most studies examining the human facial expression or other affective computing studies, they ask the person to come into the lab and perform a certain set of actions or to take a look at certain pictures and ask them to react to those pictures. This leads to performative expressions, and sometimes the person might not want to disclose their emotions at that time to a stranger. This leads to social desirability bias. A key factor to detect depression in the wild is to capture authentic expressions in the user's natural environment. To do this, we propose a new framework called MoodCapture, which is a smartphone application that captures the user's face when they answered the PHQ-8 survey, which is a well-validated depression screener. We take a picture when the user answers the question shown on the screen. This question directly relates to depression. Using MoodCapture, we conducted a study of 177 users over 90 days, capturing around 31,000 EMAs and over 110,000 photos. We modified the PHQ-8 scale, where each question is answered on a continuous scale from 0 to 100. And after we add up all the PHQ-8 items, any value above 334 is categorized as having depression. So if you take a look at our data set, we notice that 67% of our data set is composed of images corresponding to depression. After we collect all these photos to begin our analysis, we wanted to understand the context in which our users answer these questions. To do this, we use a visual question answering tool, in particular Blip, to investigate the environment and context of our images. We asked the VQA 5 different questions about the illumination of the image, the phone angle, the dominant color, whether the image was taken indoors or outdoors, and the kinds of background objects in the image. After collecting the VQA output, two experts manually annotated 1,500 unique EMAs to verify the accuracy of the VQA. We noticed an accuracy of over 89% with good inter-rater reliability. Our results basically suggest that there is substantial agreement between the VQA's output and what the experts manually annotate. With this, we took a look at what the VQA output was. We found that a majority of our images were captured indoors in well-lit environments with a low phone angle, which basically means that the user was holding their phone lower than their chin and looking at it from the top. After our exploratory investigation, we wanted to train a machine learning model to predict depression. To do this, we took our raw images and extracted open face features from the image. Using these open face features, we trained a random forest for two different tasks. Our first task is a binary classification problem for depression detection, and our second task is a PHQ-8 score prediction problem, which is a regression model. Next, we also train a deep model to perform both these tasks. While the machine learning model requires open face features, the EfficientNet deep model learns these raw features from the raw images themselves. Our results show that a random forest trained on 3D face landmarks performs better than the deep model. And this is in terms of the Matthews correlation coefficient for classification and the mean absolute error for the regression problem. Another important point is that random forests are also much more explainable than deep models. So we use the random forest and apply SHAP on it, which is an explainability method. We do this to identify important classification and regression features. we make two interesting observations. The first is that we notice larger coordinate values on the left cheek are associated with higher depression scores. Our second interesting finding is that eye and lip features on the right side of the face are much more important for detecting depression. A main reason for this is because of the way people hold their smartphones, which creates an asymmetry by capturing more part of the right side of the face. After our study, we conducted a survey to understand our users' comfort levels with front-face smartphone images. Most of our participants, approximately 62%, said that they were comfortable with their pictures being taken. We asked uncomfortable participants the main reasons for their discomfort. We found 5 key areas that made participants feel uncomfortable. These areas are related to privacy, self-esteem of the individual, the data security, the participant being in inappropriate situations, or the user not having control over the pictures that are being taken. For example, a participant said that they're already paranoid when it comes to cameras and they do not like being watched. Another important aspect of naturalistic image collection is that the user does not have a control to delete their pictures when they take the picture, which basically made some users feel a certain level of discomfort. To summarize, MoodCapture shows that face images captured in the wild have the potential to detect depression, and future work will greatly benefit from using personalized models which are tuned for each user and environment. What we basically propose is that newer models must adapt to the user's characteristics and also the environment in which they take their pictures. And training such personalized models would improve the performance for it to be deployed. Through our post-study survey, we found that a lot of participants indicated major pain points that might reduce the adoption of this technology. We found that privacy, security, and lack of control are major ethical concerns. One way to address all these concerns is through a federated learning approach where the user's photos never leave their phone. So future research focusing in this area will be greatly beneficial for this line of research. We would like to thank our participants, reviewers, and the National Institute of Mental Health and also Dartmouth College for all their support. Thank you for listening to our video presentation, and if you have any questions, feel free to reach out to us.